Beyond the shimmering veil of our galaxy, where stars are born in fiery cradles and black holes hum their silent songs, the James Webb Space Telescope has turned its golden gaze to the farthest reaches of the cosmos. Nestled in the quiet solitude of the L2 Lagrange point, a million miles from Earth, this marvel of human ingenuity has pierced the ancient darkness, capturing light that began its journey when the universe was a mere infant. Its infrared eyes, designed to unravel the secrets of the cosmic dawn, have stumbled upon something extraordinary, a phenomenon so strange, so breathtaking, that it challenges the very fabric of what we believe is possible. This isn't just another galaxy or a distant star. It's something else entirely, a discovery that whispers of forces older than time itself, and it's left astronomers, physicists, and dreamers across the globe in a state of quiet wonder. If you're as captivated as we are, hit that like button, subscribe for more cosmic revelations, and let's dive into the mystery together. The signal first appeared as a faint flicker in the data, a whisper buried in the torrent of light collected by Webb's mirrors. At first, the team thought it was a glitch, a cosmic hiccup in the telescope's intricate sensors. But as they recalibrated and refocused, sweeping the same patch of sky again and again, the flicker grew into a pattern, a rhythmic pulse of energy emanating from a point so distant it lies at the very edge of the observable universe. This wasn't the chaotic glow of a supernova or the steady shine of a galaxy. It was something precise, almost deliberate, like the ticking of a clock older than the stars. The light, captured from a time when the universe was barely 150 million years old, carried a signature that defies every model of astrophysics we hold dear. It's as if the cosmos itself is speaking, and we're only just learning to listen. This phenomenon, detected more than 13.6 billion light-years away, originates from a region of space that predates the formation of the first galaxies. To put that into perspective, the light we're seeing now began its journey before Earth, before the Sun, before even the concept of a solar system existed. The universe back then was a turbulent sea of plasma, a place where matter was just beginning to coalesce into the seeds of stars. Yet here, in this primordial chaos, Webb found something structured, something that pulses with a rhythm so consistent, it feels almost alive. The energy signature is unlike anything we've seen, not the fiery birth of a star, not the violent roar of a quasar, not even the faint glow of a galaxy in its infancy. Instead, it's a sequence of light bursts, repeating at intervals so precise they could be measured with a metronome. Each pulse carries a spectrum that dances across the infrared, with peaks and troughs that seem to follow a mathematical harmony, as if tuned to the fundamental constants of the universe. What makes this discovery so startling isn't just its age, but its complexity. The source spans a region of space roughly 200,000 light-years across, larger than our Milky Way, yet impossibly coherent for something so ancient. The light doesn't scatter chaotically as you'd expect from a natural phenomenon at such a distance. Instead, it's synchronized, as if every point in this vast expanse is working in concert, like a symphony played across the void. The spectral data reveals something even stranger, traces of elements that shouldn't exist in such an early universe. There are hints of heavy metals, elements forged in the hearts of stars that hadn't yet had time to form. It's as though this phenomenon bypassed the slow grind of cosmic evolution, emerging fully formed in an era when the universe was still learning to shine. Astronomers have run every simulation they can think of, trying to explain this anomaly through natural processes. Could it be a cluster of primordial black holes, their accretion disks singing in unison? Could it be a rare alignment of early stars, their light somehow amplified across eons? Every model fails. The laws of physics, as we understand them, don't allow for such a structure to form so early, let alone emit light with such precision. The pulses are too regular, the spectrum too complex, the scale too vast. Some researchers have begun to whisper a possibility that feels almost forbidden. What if this isn't natural at all? What if we're looking at the echo of something built, something designed, something that predates not just humanity but the very stars we call home? The implications of this idea are staggering. If this phenomenon is artificial, it suggests an intelligence that operated on a scale we can barely comprehend. Imagine a civilization that didn't just harness the energy of a star or a galaxy, but wove a network of energy across hundreds of thousands of light-years, a lattice of light and matter that has endured for nearly the entire history of the universe. Such a civilization would be beyond our wildest dreams, operating at a level that makes our most advanced technologies look like sparks from a flint. They would be architects of the cosmos, shaping the fabric of space-time itself. The pulses we're detecting could be the remnants of their machinery, a signal meant to endure, a beacon announcing their presence to anyone with the tools to see it. Even if we set aside the idea of intelligence, the discovery forces us to rethink everything we know about the early universe. If this is a natural phenomenon, it means matter and energy could organize into complex structures far sooner than we ever imagined. The universe, in its infancy, wasn't just a chaotic soup of particles but a place where order could emerge, where patterns could form, where complexity could take root. This could rewrite the timeline of cosmic evolution, suggesting that the conditions for life, or at least for intricate systems, were present not billions of years after the Big Bang but within its first heartbeat. It's a universe that's not just vast but vibrant, not just ancient but alive with possibility. The data from Webb has sparked a frenzy of activity across the scientific world. Observatories on Earth and in orbit, radio telescopes, X-ray detectors, even gravitational wave observatories are now trained on this distant point, searching for any clue that might unravel the mystery. Yet so far, only Webb's infrared vision has captured the phenomenon clearly, as if it were designed to be seen by a telescope like this one. That thought alone sends chills down the spine. Could it be that this signal was meant for us, or at least for a civilization advanced enough to build a machine like Webb? The idea feels like science fiction, but the data is real, undeniable, etched in the light that has traveled for 13.6 billion years to reach us. The phenomenon's gravitational effects add another layer of intrigue. By studying the way background light bends around it, astronomers have inferred a mass that doesn't add up. The source is massive, far more so than any galaxy or cluster from that era should be, but its gravitational pull is strangely diffuse, as if it's not just matter, but something else, something that warps space in ways we don't yet understand. Some theorize it could involve dark energy, the mysterious force driving the universe's expansion. Others suggest it might be a new kind of matter, something beyond the standard model of particle physics. The most daring propose it could be a network of energy conduits, a cosmic grid that channels power across unimaginable distances, defying the limits of entropy itself. What's perhaps most haunting is the rhythm of the pulses. They're not random but follow a sequence that mathematicians have begun to analyze. The intervals between bursts aligned with ratios found in nature, the golden ratio, the harmonics of pi, the constants that govern gravity and light. It's as if the phenomenon is singing a song that resonates with the underlying code of the universe. Some have even suggested modeling the pulses as a kind of proto-language, not words but a pattern that conveys meaning through its structure. Whether it's a natural resonance or a deliberate signal, it feels like the universe is trying to tell us something, and we're only just beginning to decode it. This discovery doesn't just challenge science, it challenges our place in the cosmos. If this is the work of an intelligence, it means we're not alone, not just now, but across the vast expanse of time. It means that long before Earth formed, something or someone was out there, building, creating, leaving behind a legacy that still shines. It means the universe has a history we're only now glimpsing, a story written in light and gravity, waiting for us to read it. Even if it's natural, it suggests the cosmos is far stranger than we imagined, a place where complexity and order can arise in the blink of a cosmic eye. The James Webb Space Telescope has given us a window into this mystery, but it's only the beginning. New missions are already being planned, probes to study the phenomenon up close, telescopes to capture its light in even greater detail, experiments to probe its gravitational shadow. Every observation brings us closer to understanding, but also deeper into the unknown. This isn't just a discovery, it's an invitation to rethink what's possible, to dream bigger, to look farther. The universe has always been a place of wonder, but now it feels alive, pulsing with secrets that have waited billions of years to be found.